Hello everyone. For this session, I'm going to introduce to you what Ohm's law is. And then for the next part, I'm going to show you how to clearly differentiate the difference between Ohm's law and resistance of a conductor, which is actually a common misunderstanding by many people. Now, we're going to start with introducing to you what Ohm's law is. On the top right corner, I have a resistor X, which is connected in a circuit. Voltmeter is connected across X and ammeter is connected in series to X. Now this is a very simple setup, a very simple experimental setup to collect the current flowing through X and the potential difference across X. And using this setup on the top right hand corner, we can actually plot a graph of I against V, which is on the bottom right left hand corner. After plotting the points, we get a perfect straight line passing through the origin. And from this graph, we can say that I is directly proportional to V. If you can recall what you covered in your mathematics lesson, we get this graph. In maths, usually is yx. So you get y is directly proportional to x. So in this case, y is directly proportional to v. In mathematics, y is directly proportional to x is actually y equals mx. And over here, we just let k be a constant, where k is the gradient of IV graph. K is the gradient of this IV graph. What this graph shows us is that the current is directly proportional to V. That's all it shows us. And that is actually Ohm's law. Ohm's law states that the current is directly proportional to the potential difference across the conductor, provided that the temperature and other physical factors remain constant. So that's what Ohm's law tells us. So how is it easily confused with resistance? Now, to calculate resistance, I need to first identify a coordinate on the line and then get the corresponding V and I value. And in this example, the V equals 20 and I equals 0.8. And from an earlier video, we learned that resistance is actually the ratio of the potential difference across the conductor to the current flowing through the conductor. Because of this, we know that R equals V over I. And V, we have 20, I, we have 0.8, and hence we have 25 ohms. Okay, so it's 25 ohms, right? That's it. That's actually the difference between resistance and Ohm's law. Ohm's law merely tells you that the current is directly proportional to potential difference and your IV graph is a perfect straight line. And resistance, you just take a coordinate on the graph, get the corresponding V and the corresponding I, V over I, that will give you the resistance. So what's the point of having Ohm's law? In the next slide, I'll show you two components which do not obey Ohm's law. Now on the left here, you have the IV graph of a light bulb, which does not obey Ohm's law at all, and on the right is the IV graph of a diode, which also does not obey Ohm's law. And because they don't obey Ohm's law, for each of these components, their resistance actually changes for every value of V. Let's take the light bulb for example. What we are trying to illustrate here is, let's take a light bulb. Let's say if I have this, I take this value. Let's say this is A, this is B. And I take this value. This is C. This is D. Right? Now, resistance of a light bulb, I call it R1, which can be equals A over B. And the second resistance is C over D, depending on the potential difference that you put across the light bulb. And what I'm trying to show you here is that because they do not obey Ohm's law, A over B is not equals to C over D. However, in the first one, okay, I use a different ink now, right? Let's say I choose a purple ink. Okay, in the first one, if I choose 5 and I choose 2.2, so V equals 5 and I equals 0.2, so my R equals V over I equals 5 over 0.2, which is equals to 25 ohms. So that means for Ohm's law, the resistance value is actually constant, whatever value of V. I say again, if the component obey Ohm's law, its resistance is constant for whatever value of V. But for these two components that do not obey Ohm's law, their resistance value changes for every value of V. So for these two conductors, we call them non-ohmic conductor. And for the one that obey Ohm's law, we call them ohmic conductor.